Okay, so this section deals with functions and relations, and we're also going to be dealing with domain and range. A relation is any set of ordered pairs. So anytime you see an input and output or x and y set up like this, that's considered a relation. A function is a relation for which every input there's exactly and only one output. So you can see here 1 has an output of 2, 2 has an output of 4, 3 has an output of 4, 4 has an output of 5. Whereas over here, this input 1 has two outputs, 5 and 7. So in a question like this, which of these relations is a function, you could say that this one is, and this one is not, because it has two outputs. So your relationship or your explanation of this could be 1 has multiple outputs, and your explanation for here is all of these only have one output. Now there is another way to determine whether something is a function, that's by looking at the graph. In this, we can use something called a vertical line test. So a vertical line is up and down. A lot of times I'll take my pencil and I'll just scrub it over the graph. And basically a vertical line says if it intersects a graph at more than one point, then it would not be a function. So if I use this screen, I use this kind of as my edge or my pencil in my vertical line, and I drag it across the graph straight up and down, you can see that this only intersects this line at one point along each way. So that would be considered a function. Whereas over here, with this graph, you can see that it is intersecting at multiple points. So as long as it's intersecting at more than one, it would not be considered a function. So you can use a vertical line test to determine whether it is a function, and that can be your explanation as well because it has multiple inputs. You know, this would be our x value. So at like negative whatever this number would be, you can see that there's 2 points of y that line up with that. All right, so yes and no based on that vertical line test, which is essentially the same idea behind looking at multiple outputs. Okay, so now we have our second part, which is domain and range in a graph. So our domain are all our x values, which is our inputs. When we set up and we were solving for y by inputting in for x, if I had 1, 2, and 3, you know, let's just make up outputs of 4, 5, and 6, then the domain for x here would be 1, 2, and 3, whereas the range would be 4, 5, and 6. Now this is a set of numbers that are given to you, but if we're dealing with graphs that could go on in either direction, there's different ways that we can write that, and that's what we're going to practice here with these graphs. So if you look at these, describe the domain and range of the following graphs, and you can see that this is a filled in circle, this is an open circle, so that means it's greater than, less than, or equal to, based on whether it's underneath or it includes that number or not. So all of these have a start and an end based on the graph. So we need to look first, if we're going to look at our domains, we're looking at our x values. So now our x values, remember, are this axis. So what points of the x value, so you can see it's at -5 and it goes all the way to, and this is our origin, which is 0. So this line falls between this set of numbers for our x. So you can see that it's less than 0 and greater than -5, or I should say or equal to here. So we can write our domain. One way we can write our domain is saying that x is greater than or equal to -5 and x is less than or equal to 0, because that covers that range of this graph. Now when we're talking about the range, that's our y values. So we're going to be comparing the y values that this graph covers. So if I look at this, it looks like it goes from 4, then it goes all the way down to which would be -1. And because it's a filled in circle, it includes those numbers. So in this case, y is all numbers less than or equal to 4 and greater than, which would be -1 on our y. So y is greater than or equal to -1. So that's how we would list our domain and range. So we're looking at, again, if our x values are here, remember this is our x values, so this goes all the way from 4, then at this part on x, it is 0. So this whole graph falls within these points for our x. So if we look at it, it would be greater than 0 greater than 0, and it's less than 4. And I'm not going to put the line underneath because it's an open circle. So now let's look at where our y values, that would be considered our range. So we're at 4, so this graph goes all the way from 4 down to -4, but it does not include those. All right, so you can see it falls within this range of the y. So I can say y is less than 4, but y is also greater than -4. All right, so that's how we list our domain and range of a given graph. Sometimes the graphs go on forever. We can say it includes all numbers, it goes on for infinity, but these are giving you boundaries so you can get used to seeing how that works. All right, so again, we're looking at our range on, or our point values for our domain, which are x values. So you can see that this, between 2 and 3, and again, this kind of helps right here. So you can see between 2 and 3 is where this graph goes. So the way I would write this is you can see that it's going to include numbers that are greater than 2. So x is greater than or equal to 2 because it's filled in. But also x is less than 3. And I'm not putting the line underneath because it's an open circle. All right, so now where do the y values pertain to this? Well, here's my y value. So it starts at 3 and it goes down to 1. So we're looking at these numbers here. So I can say y is, and it's going down, right? So y is less than or equal to 3 because that's filled in circle, but it has to be more than 1. So y is greater than 1. And I'm not putting line underneath because it's an open circle. All right, let's try this next one. So over here, we're looking at our domain, which is our x values. So look at all the points that this graph covers on this axis. So you can see it goes from -2 all the way to 3, and it includes 3 on there. So drawing these lines may help you visualize that. So we're going from -2 to 3. So x has to be greater than or equal to -2 because it is including that. And they're closed circles here. So x is less than 3. All right. So now we have to look at our y values for this graph, and I'll draw that in red. So remember, our y values are up and down. So you can see the highest this graph goes is 1. The lowest it goes is -1. So when I'm writing that, I can say y is less than 1. And I'll say less than or equal to 1. And y is greater than or equal to -1, because that's how far low it goes. So that would be considered our range, all of those numbers. All right, last example here, and I'm going to do one other example too, but our domain, again, it's our x values. So our x values go from -5 all the way, and this graph goes all the way to here. So again, all the way to 5. So our x is greater than or equal to -5, and it's less than or equal to 5. And our y values, where this graph covers from my up and down standpoint, would be this point. So up to 2 and down to -2. So our y would be less than 2, so less than or equal to 2, and y is greater than or equal to -2. Now a final example, and these all have starting points and ending points. So if I had something like just a line like we've been graphing, let's say I have this, and the line goes on forever in either direction. So there's no lines to draw here because this is our x value, this is our y value. So how would we write our domain and range for this type of graph? Well, it's going on forever, so we'll continue to cover these x values, and it's going on forever this way, so we'll continue to include all of those x numbers. So our domain would be all real numbers. Or we can write an infinity symbol, which looks like that. All right. Our range, which would be our y values going this way, and again, this is covering all the y values going up from here and all of them going down. So again, our range could also be infinity, or we can say all real numbers. There's times where you might see a graph like this, where maybe it starts at this point and then goes on forever. So this would have a different range. Let's call this 1. All right, so our domain for this type of problem, and again, it's our x values. You can see that this graph does not go past 0 on our x-axis. So this would be all numbers. So x is greater than or equal to 0, because that would include infinity going this way. And our y value, you can see that it doesn't go below 1. So for our range, but it does go on forever this way, we can say that y is greater than or equal to 1. So that's how we could display our domain and range in a graph, someone like this. But if they have a starting point and end point and they don't have the arrow, then we can set parameters on our domain and our ranges based on the graph.